So in chapter 7, we are talking about how to work with what are called oblique triangles. And an oblique triangle is basically not a right triangle. Our SOHCAHTOA definition requires us to have a right triangle. If we're going to do opposite, adjacent, and hypotenuse, we only have a hypotenuse if we have our 90-degree angle in the triangle. So this is talking about what we can do if there isn't a right triangle. And our option is what's called the law of sines. You do not have to memorize this. It would be on the formula sheet. But I want you to write this down and then we will talk about it. Just as a refresher, and this is talking about in any triangle. So it does work in a right triangle, but it doesn't have to be right. We know the capital letters represent the angles. Side A is the lowercase letter. It's across from angle A. Side B is across from angle B. Side C is across from angle C. So the capital letters are angles, the lowercase letters are sides. This tells me I can take any two of these and set up an equation to solve. So it says the ratio of a side over its angle is equal for every pair here. All right, the easiest way to make sense of this is to just look at an example and show you how we would do it. So I want to solve triangle ABC. That means find all the angles and all the sides. I have it. Angle A is 32.0 degrees, bless you. Angle B is 81.8 degrees. Side A is 42.9 centimeters. Okay, the easiest thing to find is angle C. How would I do that? That would be true for this.
Add the two angles.
Right. We know in any triangle the angles add up from 180, so you can do 180 minus both of those angles. So side C is, or angle C is 66.2 degrees. Okay. We have, in order for us to be able to use this formula, we're going to need like an angle side pair. And I have it. I have angle A and I have side A. So in my law of sines, I'm going to use that. If I wanted to find side B, I could say A over sine A is equal to B over sine of B. And now we plug in. A is 42.9 over the sine of 32 degrees equals B, I don't know, over the sine of 81.8 degrees. So how would you find side B? And you can cross multiply, or all you really have to do is multiply over the sine of 81.8. So just plug it in the calculator. Sine 81.8 times 42.9 divided by the sine of 32. You could round however you wanted. How many significant digits were there in this problem? 3. So if I wanted to answer with significant digits, I could say 80.1 centimeters. If you don't answer with significant digits, my directions didn't say you had to, so I'm not going to count off. You can give me more if you would like. Okay, at this point, can I just say, I know A and B, A squared plus B squared equals C squared? Why not? It's not a right triangle. Okay, that's what we've always done, but all semester long we've been dealing with a right triangle. We don't have that, so how do I find C? say A over sine A is equal, this time I'm looking for C, so I could do C over the sine of C. So side A, 42.9 over the sine of 32 degrees. I don't know side C, but I know angle C is 66.2 degrees. So we can just multiply that over and plug it all in the calculator. And what do we get?
74.1.
Whenever possible, I like to use the numbers given in the problem. So I could have said like B over sine B is equal to C over sine C. But since I had found side B myself, I just went back and used A since that was what was given to me. Just make sure you are showing work, because especially if you're rounding to significant digits, you could get a slightly different, like by 1 decimal place perhaps, if you use the rounded number for side B versus the side A that was given to us. Remember, with our significant digits, sometimes we have different answers depending on which number you used. So just make sure I have enough work to understand how you got to your answer if you're off by a decimal. As long as the work matches, it's no problem. Okay, what questions do we have there? I'm trying to throw in some problems to review some other things as we go along, but let's try another one like this. So we talked about significant digits again as a refresher. We're looking at this. Do you guys think you could try setting this one up to start it? See how far you can get. I'll give you a couple minutes. Do everyone get angle B to be 48.6 degrees? For my ratio, which angle side pair do we have? C. So I'm going to have to use the C over sine C. So if I want to find A, I could say A over sine A is equal to C over sine C. So if we plug in side C, 25.3 over the sine of 102.6 equals, I don't know A, over the sine of 28.8 degrees. So if you multiply it over, what'd you guys get? 12.5 or 12.49? What would my label be on that one? And so we could do B the same way. So C, 25.3 over the sine of 102.6 equals, I don't know B over the sine of 48.6. And what did you get for that one? 19.4. How did we do? A little bit easier than the stuff we were doing before. And you don't even have to memorize the formula. It's all going to be given to you. Okay, let's try just a couple more. So Kurt Daniels wishes to measure the distance across a river. He determines that angle C is 112.90 degrees, angle A is 31.10 degrees, and side B is 347.6. Find the distance A across the river. Okay, you could do a whole picture, but all you really have to know is we're looking for side A. We don't have a right triangle, so we have to use the law of sine. So A over the sine of A, which one would we need that to be equal to? so we need to find angle B. So angle B is what? And what do we get for A? Trying to be nice. My peace offering after yesterday. I know you guys, we didn't have as much work time as I took for in class. I posted the chapter 7 homework. I just made one document this time, but I think it's like 6 questions maybe for the 7.1. So you should have enough time to get that done.